Okay, so section 5.7 is on point slope form. So we're going to use the y minus y equals m times x minus x. That's our equation where the second y and the second x get replaced with the coordinates from the point, the x and y coordinates from the point. Always remember that you're going to keep the first y, keep the first x, substitute the second ones. So in section 5.6, I showed you how to graph a line using a point and a slope, but I'll review it again here in this section. So you plot the point, you use the slope from that point, and you connect the dots. So if we're given a point -2, 1, and a slope of -3/5, we can graph this line by first plotting that point, -2, 1, right there, and then using the slope. So we're going to go down 3 units and over 5. And we're going to get that point right there, which is 3, +3, -2. So our point +3, -2, and then we have our line that goes through there. So that's how we graph if we were given a point and a slope. I said it's not much different than if you're given a y-intercept and a slope. You're just starting from a different point. So how do we write the equation for this line? So we're going to use the point slope form, y minus y equals m times x minus x. We're going to use the point -2, 1, and the slope of -3/5. Well, first off, we're going to put that slope in there, -3/5. Said we're going to keep the first x. We're going to replace the second x with the x coordinate from the point, which is -2. We're going to keep the first y, replace the second y with the coordinate from the y. Now those minus signs are important. You keep those in there. You don't replace them. So when you have a negative number that you're replacing in there, I would say put the parentheses in there so that you know I replaced a negative number, but I kept the negative from the equation. Now we're just going to simplify that down because we have those two negatives next to each other. So it's going to become x plus 2. So we're just doing a substitution there. We're not really doing any calculations other than maybe a little simplification down with negative signs. But how do we take that equation that's in point slope form and convert it to slope intercept? It's nothing more than taking this equation and solving it for y. So y minus 1 equals -3/5 times x plus 2. So you get the y minus 1 equals -3/5 x plus a -6/5. So we have that. Then we're going to take this 1 and we're going to move it over this way. And we're going to change the sign of it. Y equals -3/5 x plus a -6/5 plus 1, because it was -1 there. We're going to make it +1 here. But I'm going to write it in terms of fifths so that I can add those together. Y equals -3/5 x minus 1/5. And that's our equation in slope-intercept form. So if we go back to our graph from the previous, we should be crossing the y-axis at -1/5. So I'm going to go back there and look and see if we're close. -1/5, yeah, I'm below the 0, in between 0 and -1. So I would claim that that's -1/5 for my y-intercept. Okay, so we can put a point in with a slope. We can convert it to slope-intercept from point slope. So now what happens when they give you 2 points? There isn't such a thing as a point-point equation of a line, but with 2 points, we can calculate the slope. So we're going to look at 2 points. Let's go 2 points of -1, 2, and 4, -23. And we don't want to graph those out, do we? No, because that 23 is just too big. So we're not going to worry about graphing it. We're going to calculate the slope, and the slope is calculated by taking the difference in the y's, -23 minus 2, over the difference in our x's, 4 minus a -1. 23 minus 2 is a -25. 4 minus a -1 is a +5. So when we simplify it down, it becomes a -5. Now that we have the slope, we can pick either one of those points. I'm going to pick both of them, but at different times. So I'm going to take that first point, -1, 2. Y minus 2 equals m, which is -5, times x minus our -1. Y minus 2 equals -5 times x plus 1. There is our point slope form. Simplified down. Now I'm going to use the other point, 4 comma -23. So y minus a -23 equals our slope of -5 times x minus our x coordinate. And we're going to simplify down those two negatives. Now those two don't look like the same equation. At least I don't think they do. To me, they look kind of drastically apart, other than they both have the slope of -5. But if we went and converted each one of these to the y-intercept, we will see something here. Y minus 2 equals -5x minus 5. Just distributed out the 5. Now I'm going to add 2 to both sides, or move that 2 over, and it's going to become positive, -5x minus 3. Same thing over here, distribute out the -5, and we get -5x plus 20, because the two negatives make a positive. We move the positive 23 over to that side, it becomes negative. So we have 20 minus 23, which is -3. Now you can see that those two equations were actually the same equation, just in different form. So it doesn't matter which one of the points you use when you go, after you calculate the slope and use the point slope form, when you're given originally 2 points. So in kind of a summary of how we can come up with equations of the lines up to section 5.7, we can do that if we know you have 2 points. If you know you have 2 points, you calculate out the slope and use the point slope form. If you know the slope and the y-intercept, use the slope-intercept form, the y equals mx plus b. And if you know the slope and 1 point, you use the point slope form. So both of the blue ones, you're using the point slope form. The red one, you're using the slope-intercept.